we need to transition to our last speaker in this session. It is my pleasure. Thank you, Alex, for showing your screen, and we can probably hear you as well. Checking.
Good morning.
Great. So let me quickly introduce Alex Koons. Alex is a principal at AG Koons, a company focused on systemizing the construction industry to an integrated approach to design and construction. Alex is joining us from Silicon Valley, California today. He will share his perspective on integrated design and construction and how this is being achieved in data center infrastructure delivery. Okay, a bit more about Alex very quickly. Alex and his company are particularly focused on the global data center industry, and today he's obviously talking about that. He's going to share with us what he's doing with model-based design, analytics, and the application of project production management. Alex is a member of the Project Production Institute Industry Council. He has extensive amount of experience in delivery. Professionally, in terms of who he is a bit more, he received a Bachelor of Science degree in Mechanical Engineering from Cornell University. He is also a professional engineer in the state of Colorado. He led the services group at Gary Technologies for several years. And prior to that, he has actually deployed PPM-based solutions, including computer-aided production engineering at projects such as Heathrow Terminal 5, which, by the way, is where I met Alex back in 2003. So yes, 17 years ago. It's amazing. Alex, it is great to have you here, and welcome to the 2020 annual PPI Symposium. And please proceed to share your screen, and the stage is yours. We can see it now. Thank you.
Outstanding. Thank you, Roberto. And thank you, PPI. I'm glad to be here. And it's my duty to say I'm the last presentation standing between you and the lunch buffet, or the breakfast buffet, or the dinner buffet, wherever you may be. So let's have some fun. We'll talk about data centers and our work on the design and construction of these amazing products. They're very much a part of our time, and I've seen dramatically increased usage in the last couple of months. So as we say, the fundamentals are quite strong in the data center industry right now, but we're faced with tremendous difficulty in the execution side right now. Our work is really focused on the what and the how. What's in the box, as we say, what's in the data center design, and then how are we going to build it? And we're less focused on the who and the when. As Roberto said, I started my career on projects like Heathrow, where we did encounter enormous infrastructures of schedulers focused on who and when, wondering why their projects were chronically late and unpredictably expensive. So we use the PPI framework as a company today. We're very focused on simulation, visualization, virtual and mixed reality, things like that. We're very much, as just a part of our daily work, focused on model-based design. We build computer models, 3D computer models for everything. And as we've extended that work across multiple projects, the opportunity for analytics presents itself. And our clients ask things like, hey, it takes me 3 to 6 months to get a cost estimate. And we say, well, that should take 2 minutes. We have all this data. We're very focused up front on model-based design. Analytics should just play a daily role in what we're doing. So we introduced that. As we've had more and more data extended out across our program of projects, the opportunities for machine learning have presented themselves for using reality capture, 3D scanning, things like that, for controlling execution in the field and really just verifying what's there and does it comply with design intent. That's a big part of our work now. And then we'll get into robotic process automation towards the end of our slides. So why are we here? What's the big deal? Our clients are looking for really three things. One is time to market to satisfy their customer demand. And as you could imagine, the demand for cloud services is exploding. So customers are banging down the door saying, I want more. There's also a very fertile marketplace with a lot of competition right now. We're going to look at what that means. But competition for cloud services between Amazon, Microsoft, Oracle, Google, IBM is tremendous right now. The industry is faced with a developing supply chain. And we're going to talk about what that looks like in a second. It really begins with AWS pioneering data centers for cloud really not that long ago. So the supply chain, we shouldn't use words like it's immature. We're just building a product that simply didn't exist 20 years ago at the scale that we're doing it now. And some numbers to present how large the marketplace is around the world and its growth rate. It's maybe less important what the actual figures are, but they're growing. They're tremendous in scale, and the opportunity for success or failure is huge. So let's talk about what the data center is. There's a seminal book called The Data Center as a Computer. That's what this diagram is taken from. It's an incredible read on the role of and the development of warehouse scale computing and the architecture of the data center effectively as a computer. And you can begin to interpret these massive facilities as a computer with a motherboard and various nodes attached to it. We see the scale on the right side here, just for context, that there's enough power going into that building that could alternately power a small city. And then the sites for the big tech companies that are building these data centers, they'll put multiple of those on one site. So big facilities, lots of infrastructure. It's largely about power, moving electrons into the computers for processing, and then evacuating heat. And there's so much heat that we can't just use air to get it out. There's a tremendous amount of processed water systems. So that's why we have cooling towers, chillers, things like that, that are extracting the heat out from the facilities. So the approach over time has developed. It was a little Wild West, really not long ago when Roberto and I were building airports and working on other kinds of projects. There was a early set of pioneers building out these massive scale data centers for the first time, based on learning from IBM and others who had been building compute centers for quite some time. Even as a kid, I remember going into my father's computer. It was the size of a room. It was at California Pacific Medical Center, and it had less RAM than what's in our telephone today. The early pioneers really just got it done. There wasn't so much focus on how the building was put together. The demand for search and ads far exceeded any systematizing. As the tech companies began to mature, there was a focus on regional program management, very conventional establishment of project controls groups to manage execution and to manage contracts. And the consequence of that was predictable unpredictability in cost, schedule, and in the finished product. And we could describe that as the snowflake era, where many of the data centers being built look different for a variety of reasons. And our go forward plan in our work with our clients is on developing a global production system. And let's talk about what that looks like. There's more artifacts on the scale of what we're up against. When we talk about the production system, there's three things that we're introducing into the program. The objective is to drive predictability, reuse, to free up cash so it's not tied up so early in design, and to accelerate design and construction. So there's three vectors, three techniques that we're using so far: product architecture, configuration-based design, and then industrializing the manufacture, the production delivery. So first topic we'll touch on product architecture. Stephen Eppinger and Carl Ulrich out of MIT have some really great courses and books and knowledge on just this concept of product architecture. And it's really the work breakdown structure, but in a physical sense, or the arrangement of functional elements into the chunks of the building. And they cite 3 different types between slot, bus, section. If we were all in a room, I'd ask a question: what do you think a building fits into? In this environment, I'll just discuss it a little bit. Most of our buildings tend to be slot modular. We build a steel structure, and then it has unique interfaces for every building system that connects to it. And the consequence of that is if you take a system out, you can't put a different one in. They're all unique. That's not a big problem for a house or for a building occupied by people, that we don't change that often. Data centers are rapidly evolving. So we want some ability to change the constituent products inside it for upgrades. So we're more interested in bus or section modular approaches to design. Now, Eppinger and Ulrich looked at the building industry, and this is what they found. Inevitably, they're looking for this. They're looking for something that's more architected with predictable interfaces. And this diagram on the right, that's just exemplary, it probably exists in the schedule for this example on the left, but in the physical product, it's a spaghetti. And we're in the business of learning from other industries and applying a cohesive approach to the product design and the architecture from the start. So here's an example from Volvo. Automotive makers famously build 60, 70 plus product types from one chassis. That's the role of product architecture. There's a lot to be learned from the mountain bike industry. This is an example of the first production mountain bike from 1979 with Joe Breezer. There's been a tremendous amount of innovation in that space. And to highlight what's most important here is the industry developed incredible new products that are faster, lighter, stronger. But the real lasting consequence was their development of industry standards. So there's over 20 companies that contribute products to the bicycle on the right here from a global supply chain. And the industry was able to get together and get behind a series of geometric standards that allowed supply chains to flourish and to create a variety of products that give the customer more choice at less price. And we're looking to do just that in the data center industry as well. I mean, it's not a mountain bike. This is what our products tend to look like. This is what's getting built. Now, where we're going in the data center industry, if we extend this product architecture concept, is that in most conventional practices, there's a lot of focus on the individual parts in the equipment and these pieces that we buy from stock and then their configuration. And there's really less emphasis on productizing what sits in the middle. That's considered intellectual property. That's competitive advantage. And what we're seeing is an opportunity to begin bundling more and more of the parts and equipment into built up larger products for power distribution, for cooling. And the use of standards will allow us to increase the supply chain as well. We use some techniques and tools from companies like ID Consult that are based in Germany, who have software that's been very effective at creating maps for defining product architecture, and then building links between the functional requirements and product design. The reason why we do all of this is to get to configuration-based design. We don't want our designs to take on the order of months to years, but we think we can accelerate that by having a configuration approach as opposed to a more invention-based and design-based approach. So we use PLM systems for that. They capture the product and the process, creates a catalog. The whole point of doing that is to get to a vision of designing the data center in a day. If our current order of magnitude to design the facility is on the order of months to years, but the program is going worldwide, we really need to find ways to accelerate that, create reuse, allow the production system to behave a little bit more like Toyota building Tacoma trucks, as opposed to the current one-off snowflake era. So tying the configuration-based approach that we have to design into execution, we're interested in how we move artisanal, handcrafted construction from the field upstream into the factory. And we want to know, how can we apply robotics and things like that, and also shift from a more conventional approach focused on schedule and resource utilization towards product and process design, and then management of these levers around capacity, inventory, and variability, which we've traditionally not had visibility into. From the owner side, you're typically buying an outcome and you don't have ability to get into that. And so what we see on our programs is owners bringing the supply chain in closer to start defining what should the capacity, inventory, and variability, how are we going to manage for variability at the point of installation and even upstream into the factory. And in the data center space where the supply chain is developing, I wouldn't say it's immature, but it's open to growth. We're finding effectively open arms saying, yeah, let's do this together. So we're interested in robotics like anybody else. So our first step was to begin buying some robots and start exploring their application for aiding in assembly. And what we find is that immediately drives a change in the product design. And this is the beginning of our use of what models look like on the left side that you see here. But as soon as we begin mapping the process and then tying it to the product, we immediately start changing the product. So as PPI would say, we're applying concurrent engineering, product and process at the same time, where the process informs the product and vice versa. And we find this of particular importance in designing what throughput do we need and what capacity do we actually need. And this has allowed us to take our projects from a more conventional bidding procedure, where a contractor's buying the job, where we flip that around and we're now able to sell the job. We have the product, we have the data behind the product. We know with vicious accuracy what's inside the box, down to the bill of materials level of detail. So knowing that, we're then able to sell the job and then work with the supply chain on designing what is the throughput that we need to hit the milestone objectives. And in the face of that, our milestones are able to be defined by what the customer actually needs, as opposed to what the project will support. So we're now in the process of crafting not just what the field looks like, but what the factories that produce products for data centers begin to look like as well. So we've taken our product data and started crafting virtual factories around them, and we'll be building out these actual factories entering into 2021 this year. Roberto, that's my last slide.
Excellent, Alex. This is quite impressive. So thank you so much. Very impressive stuff. No doubt you have not stopped innovating over the years since we both met back in 2003. So look, we have a few questions here for you, and we have also a few minutes left. So let's go through some of them. The first one here is the vision that you brought to us today. Do you think is applicable to oil and gas, or do you think this is something particular to the characteristics of data centers? Somebody asked.
Yeah, data centers are fascinating because they're like a Swiss watch on the inside, and the profile in our company, they're mostly mechanical engineers. We have a handful of architects too, and we have them architecting systems. And we're very focused on projects that are not occupied by people. We've actually done some work in conjunction with SBS in the oil and gas industry. And so, yes, I think it lends itself very well to productizing its work, and particularly anything involved in interface management, where you're just trying to bring system noise down in the product designs so that you have consistent interfaces, not knowing what the next generation of product may bring. That lends itself really well. And what we're finding is that as we stay upstream on the design side, we make the work of applying PPM in the production sense and in the field much easier because we've stabilized the product design.
Excellent. So one thing that you mentioned that really it seems that is taking people's attention is this idea of concurrency between process design and product design, right? Because I think one of the messages you share with us is that it's not just about standardizing the product, right? Meaning what we're building in the case of your story in data center construction. So can you tell us more about this comment you made? The question is the concurrency, and sometimes people are saying it's difficult to do. So what is your take on that?
It is, but we all grew up as builders, so we can't even look at a design without thinking about how's that going to be built. And in the case of our customers, they've just simply had to decide, are they in the business of regional program management, which is a contractual function, more economic than technical, or are they in the business of designing and managing a production system? And if it's the former, they really never need to even see the design or the schedule. And if it's it will have unpredictable results. And if it's the latter, then you really need to get way deep in the design as the owner team, because you hold the requirements and then develop concurrently the products in the process. And what we've been doing is cataloging not just reusable product designs, but reusable processes.
Excellent. Yeah. So, in my experience as well, if we share some thoughts, I mean, there's a lot of blind spots, I think, in project teams when they look at the processes required to execute the projects, right? And we're not talking about the schedules, right? Because we're talking about how you do things, right? And I think that's the animation you show us is quite impressive, because that is how you're making things, how you're engineering things, how you're installing things, right? Especially coming from owners, right? Those that own the data centers. So the other comment you made that also personally took my attention is that what you're telling us that owners are not really waiting for contractors to do this. They are taking the bull by the horns, if we can use that saying, and because it's their money, because it's their capital, and they're looking for more efficiency. Is that true?
Absolutely. Yeah, absolutely.
Okay.
Particularly for complex capital projects. And in the case of a data center, half the products going in are designed by the owner themselves, meaning computer racks and servers. There's an incredible agency called Open Compute Organization that's looking to share industry best practices in the hardware space around racks. They're now pointing their attention up above the racks to the cooling and power distribution, simply because the demand far exceeds capacity. And in the Wild West, early 2000s era, it was, as Roberto said, it was owners procuring turnkey projects and simply hoping for the best. And now, as the organizations and enterprises have become much more sophisticated, there's a lot more emphasis on controlling the system as a whole, the product and the process.
Okay. Thank you, Alex. We do have a couple more questions here for you. One is, it seems the tools you are using are not for 3D modeling, are not conventional tools, or they seem not to be the ones we typically know. What are you using?
So in practice, just about everything. Revit, We coordinate Navisworks, AutoCAD. We see Bentley. In our house, we have Revit, AutoCAD, SolidWorks, Siemens NX, Creo, Inventor. You name it. And what we're finding is that's less of an issue. And we have lots to say on this topic, far more than we could get to here. One axiom is that there's always a design model, which is the intent, and that tends to be symbolic in nature. And that's AutoCAD, Revit, Bentley, that kind of thing. Then there's an execution model. That's the real data that the machine uses to cut or bend or weld. Mm-hmm. And we need both. So none of us should be in the business of trying to create one model. There is no one model. There's one data set. There's one platform to host it. But there will always just axiomatically be design intent versus execution. And we need both, and we're very focused on the dance between the two, and then ensuring that the execution data is sufficient to drive the machines creating these high precision parts that we assemble into a data center.
Thank you. There's one more for you, and I think with this one we finish before we go for the break. The question is, since your work seems to be with owners of data centers, would you mind to share with us a few aha moments that you and your team might have experienced by working with, that your customers might have experienced when going through this integrated design and construction process, it says? What can you tell us about it?
Yeah, we were super lucky with one particular owner who said, why don't you just come here for 3 months and look around. I think we said, why don't we go there for 3 months and just look around? And mm-hmm. We were really fortunate to be able to just observe. And most of the time, owner teams are engaging companies with a fixed deliverable, and then there's this immediate rush to get something done. And that begins that creates certain behavior. And the first aha moment, we showed up and said, well, show us the design. And no one could really find the design because the designs were somewhere else. They were in the hands of the EPCs and the AEs, and well, they're in another state, and that guy left the company. And it was remarkable how the actual data was just out of control. It was not there. And so one of the first things we did to the patient was work with owner teams to put in place systems that just bring everything back in-house. Once it's in-house, you can unleash the analytics robots that poke around and say, hey, look, you got 25 projects. We expect to see 5% variation across them, but we're seeing 80%. They're all different. Don't we want them to be similar or more similar? And so by bringing all that data in-house, you get much more opportunities for that.
Mm-hmm. Great, thank you. I think we have probably a minute. Maybe we use that to ask you one more question. The question seems to be about what happens when a standard design of, in this case, I'm assuming it's a data center, as you shared with us, needs to be built in different locations, and there are actually localization requirements that owners need to go through. So is that turning the standard design into a non-standard design? What can you say about that?
Yeah, we plan for that. There's multiple layers of this. From a regional perspective, what you need to do in Europe is simply different than what you need to do in the US, but that tends to affect the boundary conditions of the total product, and what's happening on the inside is a little bit less unique at that point. We have some projects that assemble modules in the US and then ship them back to Europe. So for us, I think we view it as another entry in the catalog from the production system. It's just another module coming through. And then if it gets shipped abroad or gets shipped locally, that's a decision held as late as possible in the process.
Excellent. Well, Alex, conscious of time, I want to really thank you a lot for joining us this morning. Good to see you, and after so much time, and and for sharing your vision of, for some people might be a vision, for you is something happening, for some of the company you're working with, it is happening, it's happening now. For others might be, perhaps your presentation has been what could be done, right? And thank you very much again for being with us. So always learning new things from you. That's always good.